All right, our next topic here is coterminal angles. Coterminal just really means angles that end at the same place. So they're just angles that have the same terminal side or end point. Now notice right here, they give you an example right here. If you go 90 degrees, so if I start right here and go to this one, there's my terminal side of the angle right here. There's a lot of other angles that end right here. So basically, if you were to go a -1, you could go all the way back and end right that, and that would give you your -270 degrees. Or again, they write them in radians there, so we will do some of those as well. There's another one. You could actually go all the way around and then back right here to be a coterminal angle. So there's a lot of different angles that you could draw right here that are coterminal to 90 degrees. So for these examples and in your homework, they're going to ask you to give 2 coterminal angles for each of these angles. So they just want another angle, one angle that's positive, one angle that's negative, that ends at same place as 65. So notice, you're not going to have to draw this out, but I'm going to draw this out just to kind of give you a little bit of a taste. This was our 60-degree angle, 65-degree angle right there. So what they want you to do is they want you to write another angle that ends on that terminal side. So we're going to go ahead and just do this angle right here. Notice all I did is I went around the circle one whole loop. So basically you're just going to add 360 degrees to this angle. That's all you do. So it's going to be 425 degrees. That is a coterminal angle because I just added one revolution, or 360 degrees to that angle. All right, now we can find a negative angle by just subtracting 360. So basically, if you just went this way, you could just subtract the 360 and that'll give you that one. So if I subtract 360 from 65, let me grab a calculator. I miss being able to ask you guys to do the calculations here. So if I have my 65 and I subtract 360, I have a -295-degree angle. So those are what they're asking for. They want 2 coterminal angles that end at the exact same place. All right, now this is the same thing. And there's lots of different answers. So if you wanted to add 360 to this one, you could do that. And 540 plus 360 is going to be 900. And that is a coterminal angle right there. However, when we go to subtract 360, so if I subtract, let's do it in green, subtract 360 from 540, 540 subtract 360, it gives me 180 degrees. If you wrote that on your quiz, you would get marked down. You would get 1 point for the positive, but you need a negative coterminal angle. And we just have 2 positive ones. So let's subtract another 360 from that 180. We're just going to keep subtracting until we get a negative number. So you got a negative 180 degrees. That'll give you your negative. Okay, you could also just use these two. If you saw that it was going to be bigger than 360, you could use the 180 and the negative 180. So any of these angles, as long as one of them's positive, one of them's negative, and they end the same place as the angle that they gave you. All right. The next 2 examples right here, notice they are written in radians. All right, now most of my students, I know this is still brand new. We just barely introduced radians to you, and now we're trying to get you to use radians. It will get more familiar, but for right now, I know a lot of you are still a little bit new to this. I have had students that just changed it into degrees and then add 360 and subtract 360, and that's fine. If you want to do that, that's fine. Go ahead and do that. I'm going to work with this in radians though, and I'm going to say, okay, remember when we add 360 degrees, we can add that in radians too. Remember, all the way around the circle was 2 pi. So all we're going to do right here is add 2 pi to the radians and subtract 2 pi. Now, if your calculator does this, that's fantastic. Most of them will not. So you're going to want to, before you can add before you can add fractions, you've got to get common denominators. So notice this denominator here is 18. My denominator is 1. So I'm just going to kind of say, well, I can make it 18 if I multiply it by 18. I'm just going to multiply both of them. So basically, you just double whatever your denominator is, just double it all the time. So 18 times 2 is 36. So I'm going to add 36 pi over 18 to my 13 pi over 18. Leave the pi. You'll always have a pi in it. So really, you're just adding the numbers. 13 plus 36. 13 plus 36 is 49. So I've got a 49 pi over 18. That's a positive 1. And then we can also subtract our 2 pi or subtract the 36 pi over 18. So then we have a 13 subtract 36, which gives us a negative 23 pi over 18. All right, again, if you wanted to use what we just did before and multiply this by 180 over pi, that'll change it into degrees, and then you could just add 360 and subtract 360. But I like fractions, so I'm going to keep doing it with fractions. So on this one, when I add 2 pi, notice my pi's have to be written as 9. So I just know that 18 divided by 9 is 2. So this will give me 2 pi. Again, I just looked at the denominator and then multiplied it by 2 to get the numerator right there. All right, so 14 plus 18 gives me 32. 32 pi over 9. That's a positive coterminal angle. So positive coterminal angle, and then I'm going to subtract 18 pi over 9. So 14 subtract 18, that'll give me negative 4 pi over 9. And again, I found 2 coterminal angles. These angles both have the same stopping place. One more thing, you could do the same thing with this one. You could go ahead and turn that into degrees if you'd like to, and then just add 360 and subtract 360. Those would be fine answers on the assignment, on a quiz. However, the answer key is all in radians.